Hello. So let's look into today's Leetcode problem, which is minimum time to visit a cell in grid. So in this question, you are given with an m cross n matrix. You are also given with a start point and end point, which as usual is the top left corner of the matrix, and your destination will be the bottom right corner. And in this 2D matrix, you are also given with few numbers in each of these cells, which represent the minimum time uh, that is required to be able to visit that cell. So let's take an example for clear understanding. So you need to start from this cell and you want to reach this cell, and each of these cells have some values present over here, and you are given with the option to travel all four directions, and whenever you do a traversal from one cell to another cell, then you take 1 unit of time. So if you go to this place, it will take you 1 unit of time, and this cell has a minimum requirement time set to 1, so that is satisfied here, so you can reach this cell. And if you go to this cell, the time taken will be 2, that is 1 plus 1, and the minimum requirement is 1, then you will be able to traverse this cell as well. And let's take this example here, and the total time taken so far is 3, minimum is 2, so you will be able to traverse this cell as well. But here we have a requirement of 5, and if you go to the cell, right, then it will the requirement is not met, so you won't be able to traverse this cell. But you can actually traverse back, make the total time taken to be 4, travel back again, make the current time taken to be 5, and then you will be able to do traversal to this cell. So you can actually do zigzag traversals and visit this cell, and in this scenario it will be 6, and from here you can go to 7. So minimum time taken will be 7. I actually walk you through the minimum path only. There could also be few other paths which will give you 7, but all you want to do is return the minimum time taken for you to reach the end destination goal. So that's how the question looks like. And for this question, I initially used a BFS traversal. So let me quickly walk you through the code on what I did here. But it eventually proved out to give me a TLE because of bigger inputs in this question. I believe that's the reason this question is marked as hard, because the input that they have provided, right, it has a very big range. So the 2D matrix itself has a very big range here, so that's the reason. Okay. So let's go through the BFS solution. I have declared a direction array for us to travel in all four directions. I have a queue as we usually have in BFS. And then I push the start index, and this is the index, and this is the time taken to reach that index. So initially the time will be set to 0. Then what I do is do the usual thing, and in BFS traversal, whenever you get to the desired solution, right? Whenever you get to the desired cell, then it should give you the minimum time, because you are traversing the graph in a BFS manner. So whenever you encountered the cell for the first time, it should definitely give you the minimum time. So whenever I get this cell, then I return the time. And like usual, we do traversal for any cell that is, needs to be explored, and we do traversal in all four directions, and we do an additional check here, that is if the current time is greater than or equal to the minimum time for that cell, and we simply push it. So this is how simple the BFS solution looks like. But for this solution, what I want to highlight here is, here we do a lot of traversals here. Even though the intermediary traversal for a cell might not constitute to the answer, we still do the traversal for unnecessary cells, because of which the time limit gets way higher. It could prove out to be very, very high. That's the reason it got TL lead in the second test case only. So we move to the Dijkstra approach here. And one more thing that you should be noticing is, let me take one more example to make few things a little more clear. Let's take it this way. Um, so in this scenario, like I said, I actually explained the zigzag movement in this solution itself, but we can again take one more example. So you go here and you will be able to go in this direction. You will be able to go in this direction via zigzag movement. Like you start from 0, go to 1, go back to 0. It will take you a total time of 2, and if you go here, it will take you a time of 3. And from here also, if you want to reach number 20, right, we will have to do exploration on same cell again and again with different time. So we can actually save on this effort with some formula. So one thing that you should keep in mind is, if you want to reach this cell, right, and if your time is lesser than this cell, then you must be doing zigzag movement. And we don't really want to visually do a zigzag movement, because if your time is lesser than the current cell's minimum time, the cell that you want to go to, its minimum time, then you should be doing zigzag traversal. And at some point of time, once you reach this cell, the requirement will be like, the current time will be either 20 or it will either be 21. So we only need to know if it is going to be a 20 or 21. So for that, I have written this formula. I actually observed few inputs and came to this conclusion here on why it should be this way. You can do manual dry runs as well, and look and see why I've written it this way. Uh, there actually are many things to unravel in this question, to be honest. So, in order for me to save an extra effort of traversing the neighbor again and again, I have used this formula. And yeah, that should be it. So I let me simply walk you through the solution. So what I did is, I initialized an array called cost array, and like in usual Dijkstra, we set up a priority queue. We have an array for directions. We start with pushing the initial position with time set to 0 in the beginning, and we have a cost array as well. Um, and then we do the usual. Dijkstra is actually a little bit of modification on BFS only. So, like in BFS, what you do is simply pop the element from priority queue instead of queue, and you traverse the neighbor. If you find the current cost to be lesser than the previous cost, then you simply update the cost, do the relaxation, and push back that neighbor for further traversals. And here, one additional thing that you must notice is, it is not that we will be storing only 20 or 21 over here. If the current time is way higher than 2021, let's say if it is 22 or 23, then that is the time that you should be storing here. That's the reason I have made this arrangement over here. So I choose the maximum of the current time plus 1, or the calculation part. I actually feel like if I do an explanation on this one, it will take a lot of time, but it is self-explanatory, so you can try on this for a few examples. And in the end, like we are using priority key over here, so definitely the whenever you reach the final cell, right, you should be getting the answer. Okay, so and one more edge case that you might encounter is this one. So let's say this is our input. We start here, and this is how the input looks like. In this scenario, right, you won't be able to traverse to any of the cells because you don't have any partner cell to do zigzag movements over here. Initially itself you are blocked. So if you want to reach this cell, you want a total time of 20, but you won't be able to do an initial movement itself because of very high number, large numbers in its possible directions. So in such scenarios, you will be returning -1. That is what I have written in the code here. And yeah, that should be pretty much it. Um, yeah, and let me give a little explanation here again on why whenever I find this index, whenever I find a node to explore with this index, I return it. Again, it's because we are using a priority queue here, and whenever we find a better index, we simply put it in the queue and push it. But the other point is we do a BFS here, a kind of BFS kind of traversal here, because once you go from this cell to this cell, and if you try doing zigzag movements here and there, this the cost to this cell, that is basically 1 comma 0, will still be the minimum cost only, right? So every time you do a traversal on a neighbor or some other cell in a BFS fashion, it will always store you the minimum time. So that's the reason I'm actually telling you there are many things to unravel in this question. If we are able to code this by ourselves, then we should be good enough. So I think the video got a little lengthy over here, but it was actually a very good question. So yes. So thanks for watching. Bye bye.